Hello students, in this video we will discuss one interesting property of tangent of parabola. For that I consider one standard equation of parabola y square is equal to 4ax where a is greater than 0. This is the graph of the parabola. It is concave towards right hand side. It opens towards positive direction of x-axis. Here we have focus as having coordinates a comma 0. This is directrix having equation x is equal to minus a. Consider point P on the parabola having coordinates 80 square comma 280. These are standard parametric coordinates of any point on parabola. Y square is equal to 4ax. I am considering here parametric coordinates because it is easier to study conic section and its properties using parametric coordinates. Okay. Now here SP is focal length of point P. Distance SP is a plus abscissa of point P, that is 80 square. So this length is a plus 80 square. From point P, draw line perpendicular to directrix. This is a foot of perpendicular M. Coordinates of this point are minus a comma 280. From the definition of parabola, distance SP is equal to distance PM. Okay. Now at point P, draw tangent line to parabola. Equation of this tangent is Ty is equal to x plus 80 square. This is standard equation of tangent to this parabola at this point. Okay. This tangent meets y-axis at point Q having coordinates 0, 80 and x-axis at point R having coordinates minus 80 square, 0. Now what is distance R is? This distance is A and this distance is 80 square. So distance RS is A plus 80 square. This is same as these two distances SP and PM. Now if I join points R and M, then clearly quadrilateral RMPS is rhombus in which all the sides are of equal length. Now diagonals in rhombus bisect the internal angles. Here tangent line is one of the diagonals. So this tangent line at point P bisect angle SPM. This is one of the most important properties of tangent of parabola. That tangent at point P bisect angle SPM. Now if you observe here carefully, the coordinates of midpoint of SM are 0, 80. Using section formula, we can get these coordinates. Coordinates of point Q are also 0, 80. That means diagonal SM passes through point Q, which is point of intersection of tangent at point P with y-axis. Now in rhombus, diagonals are perpendicular. So we can say that foot of perpendicular from focus upon tangent line lies on tangent at vertex. This is very important finding. This is very important property of tangent of parabola, that locus of foot of perpendicular from focus upon a tangent line is tangent at vertex. Also point M is image of focus in the tangent line. So we can say that image of focus in tangent line lies on the directrix, or locus of image of focus in tangent line is directrix. Now let's use these properties to solve some questions. Now consider one parabola which is not the standard parabola. On this parabola there is point P having coordinates 7, 13. Equation of tangent line at point P is given, that is y is equal to 3x minus 8. Also focus of the parabola is given having coordinates minus 1, minus 1. Then we have to find the equation of directrix and length of lattice rectum of the parabola. Now on directrix we have point M. Can we get coordinates of this point? Definitely yes, using the properties which we discussed. Point M is image of focus in the tangent line. Now what is the shortcut method to find the image of given point in the given line? Suppose we have a given point x1, y1 and given line is ax plus by plus c is equal to 0. If image of point P in this line has coordinates x2 comma y2, then the formula is x2 minus x1 over a is equal to y2 minus y1 over b equal to minus 2 times inside bracket ax1 plus by1 plus c over a square plus b square. Using this, we can find the coordinates of point M. Suppose coordinates are x2 comma y2. So we have x2 minus minus 1 over a. A is coefficient of x in this line. Let me write this line in standard form. 3x minus y minus 8 is equal to 0. So value of a is 3. This is equal to y2 minus minus 1 over minus 1, this is coefficient of y, is equal to minus 2 multiplied by, put this point in this expression, we have minus 3 plus 1, minus 2 minus 8, minus 10 over a square plus b square, this is 10. So this ratio is 2. From this we get x2 is equal to 5 and y2 is equal to minus 3. So we got the coordinates of point M. Coordinates are 5 comma minus 3. Okay. Okay, now can we get the slope of directrix from this diagram? Directrix is perpendicular to MP. Slope of MP is 8. Using these 2 points, we can get the slope of MP. So slope of directrix is minus 1 upon 8. We have slope, we have a point. So equation of directrix is x plus 8y plus 19 is equal to 0. Now how we get length of lattice rectum? We have a focus and directrix. Using this we can get the length of lattice rectum. Formula is length of lattice rectum is equal to 2 multiplied by distance of focus from directrix. So length of lattice rectum is equal to 2 multiplied by modulus of minus 1 minus 8 plus 19 over square root of a square plus b square 1 plus 64, and this is 20 over root 65. This is length of lattice rectum. So here we have one interesting question based on this property. Let's try one more question. Now look at this question. Two tangents on parabola are x minus y is equal to 0 and x plus y is equal to 0. Point S having coordinates 2, 3 is focus. Then find the equation of tangent at vertex and length of lattice rectum. Now what is the property? The foot of perpendicular from focus upon any tangent line to parabola lies on tangent at vertex. Using this we can find foot of perpendicular of focus 2, 3 on this line and on this line, and both these points lie on tangent at vertex. Now what is the formula for foot of perpendicular from point x1, y1 on the line ax plus by plus c is equal to 0? The formula is x2 minus x1 over a is equal to y2 minus y1 over b is equal to minus inside bracket ax1 plus by1 plus c over a square plus b square. Okay, here x2 y2 is foot of perpendicular from point P on this line. Using this formula we get foot of perpendicular of this point in this line as 5 by 2 comma 5 by 2, and on this line as minus half comma half. So equation of line passing through these 2 points is 4x minus 6y plus 5 is equal to 0. Length of lattice rectum is 4 multiplied by distance of focus from tangent at vertex. Distance of this point from this line is inside modulus 8 minus 18 plus 5 over root 16 plus 36. This is equal to 20 over root 52. This is length of lattice rectum.